There is a huge difference between a helicopter that can fly itself in a test video and a military helicopter that an army is willing to accept into its own fleet. That is what makes the H-60MX Black Hawk so important. This is not just another autonomy demonstrator parked on an airshow floor. It is the first autonomy-ready, full-authority fly-by-wire Black Hawk delivered to the U.S. Army. And it can fly with a full crew, with reduced crew, under remote supervision, or with nobody at the controls at all. That changes the role of the helicopter itself. The Blackhawk stops being only a transport platform and starts becoming something closer to a reusable, robotic aircraft system that can carry soldiers one day, cargo the next, and fly dangerous missions without putting a crew in the cockpit at all. The first thing to understand is that the H-60MX is not a brand new helicopter in the traditional sense. It is a heavily modified UH-60M Black Hawk, rebuilt into what the Army now calls an optimally piloted vehicle. In March 2026, the Army officially received the first H-60MX for advanced operational testing. That wording matters. It does not mean the aircraft has already entered broad frontline service in large numbers. It means the Army now owns the first example and is moving from industry-led demonstrations into a formal military test phase, where pilots, engineers, and operators will decide how much trust they are willing to place in autonomy during real missions. Because the aircraft is based on the UH-60M, its physical size and lift sit in the Black Hawk class. A UH-60M is about 64.8 feet long with the rotor turning, about 53.6 feet across the main rotor disc, and a little over 16.7 feet tall. Maximum takeoff weight is about 22,000 pounds. The standard utility helicopter can carry 11 fully equipped troops internally and sling load about 9,000 pounds on the hook. Cruise speed is commonly given around 174 miles per hour. Top speed around 183 to 186 miles per hour, and baseline range sits in roughly the 300 to 370 mile class, depending on configuration and mission profile. That matters because autonomy does not change physics. The H-60MX is revolutionary in control logic, but it still starts from the proven lift, size, and speed of a mature medium-lift helicopter. Under the cowlings, the UH-60M family gets two GE T700 GE 701D engines, each rated in the 2,000 shaft horsepower class. Those engines, together with improved rotor blades and gearbox refinements, are one reason the UH-60M became the standard Black Hawk for modern Army service. For H-60MX, the deeper change is not engine power, but control architecture. Traditional mechanical flight controls have been replaced with a fully fly-by-wire system, which means pilot inputs or remote operator commands are translated electronically rather than mechanically. Without that fly-by-wire backbone, the autonomy layer would never be able to command the aircraft with the precision and redundancy needed for military use. The brain of the aircraft is Sikorsky's Matrix Autonomy Suite, which grew directly out of DARPA's Alias program, Aircrew Labor in Cockpit Automation System. Alias began more than a decade ago with a simple but radical idea. Build a removable kit that could be installed into existing aircraft to automate many of the hardest parts of flying, reduce crew workload, and eventually enable aircraft to fly with fewer people or no people at all. In the H-60MX, that idea has matured into a practical military package. Matrix handles mission management, navigation, automatic route execution, and autonomous flight functions from startup to shutdown. It can take the helicopter from takeoff to cruise to landing, and is designed to interface with new sensor packages and third-party software through a dedicated software development kit. That is important because it means the autonomy is not frozen in one hardware state. The Army can grow it over time. This is also why the H-60MX should not be described as a remote-controlled toy helicopter. The system is not meant to be flown only by constant joystick commands like a hobby drone. Public demonstrations have shown a much more military-usable logic. The operator enters high-level mission goals on a tablet or ground interface. The aircraft generates and executes the flight plan. And onboard autonomy manages the low-level control tasks. In one official demonstration, a Black Hawk with this autonomy architecture was commanded from 300 miles away. In another high-profile event during Northern Strike 2025, a soldier on the ground controlled an autonomous Black Hawk at distances up to 80 miles, using a tablet to plan and execute cargo, sling load, and medical evacuation-style missions. These publicly demonstrated distances should not be treated as hard technical limits. They are proof points showing how far the control concept has already gone. The DARPA connection is not just historical branding. It is the core reason this program moved faster than most military autonomy efforts. As part of Alias, Sikorsky has already built and flown a UH-60A optionally piloted Black Hawk laboratory aircraft with fly-by-wire controls and matrix autonomy. That earlier aircraft accumulated hundreds of flight hours and was used to demonstrate autonomous cargo missions, obstacle handling, and uninhabited resupply. At Project Convergence 2022, this autonomy-enabled Black Hawk performed internal and external cargo resupply missions with no humans on board. In other words, the H-60MX did not start from zero in 2026. It is the result of a long maturity path that began in a DARPA program, then migrated into Army-owned hardware. What makes this strategically important is not just that the helicopter can fly itself. It is what that does to mission planning. A crewed Black Hawk is precious because pilots are precious. A remotely supervised or optionally piloted H-60MX can be sent into roles that were previously too risky or too wasteful. That includes resupply in high-threat zones, casualty evacuation in degraded environments, logistics under chemical or radiological hazard conditions, and long repetitive cargo missions that burn out crews. The Army has already framed the MX as the forerunner for the Strategic Autonomy Flight Enabler, or SAFE, a broader effort to develop a scalable autonomy kit that could eventually be applied across the Black Hawk fleet and future aircraft. If that happens, the H-60MX becomes less a one-off prototype and more the opening chapter of a new helicopter doctrine. There is one technical point people often miss. The H-60MX is still an optionally piloted aircraft, not a cockpitless drone. That means the cabin, cockpit, and crew stations remain. The Army can put humans in the aircraft when a mission demands onboard judgment, or pull them out when the mission is too risky. That flexibility is exactly what makes it militarily interesting. A purely uncrewed helicopter is useful, but an aircraft that can switch between crewed, reduced crew, remote supervised, and fully autonomous modes gives commanders more options than either extreme. That leads directly to the next development, the S70 UAS, also branded as the U-Hawk. If the H-60MX is the crew-optional Black Hawk, the S70 UAS is the crew-removed Black Hawk. Sikorsky took a UH-60L, removed the cockpit, seats, and crew stations, and turned the front of the aircraft into additional cargo volume with clamshell doors and a loading ramp. The result is the first fully autonomous Black Hawk concept, optimized not for carrying troops, but for carrying stuff. Lots of it. The company has shown the aircraft configured to carry oversized loads such as a HIMARS rocket pod, unmanned ground vehicles, and 4 joint modular intermodal containers, twice what a normal Black Hawk can accommodate. The performance claims for the S70 UAS are what make it startling. Public figures describe self-deployment over 1,800 miles and endurance of up to 14 hours without refueling. That is a radically different mission profile from a standard crew Black Hawk. It transforms the aircraft from a medium-lift helicopter into something closer to an unmanned logistics aircraft, able to ferry itself long distances, then loiter or reposition with minimal human supervision. Public material also describes payload in the 9,000 to 10,000 pound class, depending on configuration. Again, roughly comparable to or better than the useful lift class of a crewed Blackhawk, but now without a cockpit consuming volume. Control philosophy stays familiar. Like the H-60MX, the S70 UAS uses matrix autonomy and a tablet-based mission interface. Operators are not expected to fly the aircraft moment by moment. Instead, they command missions from startup to shutdown, while the aircraft's onboard autonomy handles the flight mechanics. This matters because the more scalable model for military aviation is not every drone gets a dedicated pilot. It is one operator can supervise multiple aircraft or redirect them at the mission level while onboard autonomy does the real-time flying. That is the concept the Army and industry are clearly testing. Cost is where the picture becomes less clear. There is no public standalone unit price for the H-60MX or S70 UAS. That is not unusual for early military prototypes or derivative demonstrators. The cleanest public benchmark is the underlying Blackhawk family. Recent reporting has put the average cost of newly produced Blackhawks for the Army at about $30.5 million each. That does not automatically mean an H-60MX or U-Hawk costs the same. Autonomy hardware and structural changes could push costs up, but it gives a useful baseline. The real attraction of both programs is not that they are cheap. It is that they reuse the most widely fielded medium-lift helicopter family in the Western world, instead of inventing an autonomous rotorcraft from scratch. If similar systems are sought in other countries, the answer is yes, but not really at this scale. The closest mature Western example of an autonomous cargo helicopter is the UNMANNED UAS, which proved itself in Afghanistan delivering supplies without a pilot on board. It can lift 6,000 pounds at sea level and more than 4,000 pounds at 15,000-foot density altitude. But it is a purpose-built cargo syncopter, not a general-purpose troop helicopter. Airbus VSR 700 is another autonomous rotary wing system, but it is far smaller, with a maximum takeoff weight in the 1,500 to 1,700 pound class, payload around 220 pounds, and endurance in the 8 to 10 hour range. Both are important, but neither is a Blackhawk-class medium-lift utility helicopter that can switch between crewed and uncrewed roles. That is why the H-60MX and S70 UAS stand apart. They are not just autonomous helicopters. They are autonomous helicopters based on a platform already trusted to carry soldiers, sling loads, and operate in combat. That is the real reason these aircraft matter. The military has spent years discussing autonomy as if it were a future concept. The H-60MX makes it tangible. The first Army-owned Blackhawk that can fly with or without a pilot. The S70 UAS pushes the idea even further, turning the Blackhawk into a cockpitless robotic transport machine. One preserves the crew as an option. The other removes the crew entirely and gives the volume back to the mission. Together, they show two different futures for rotorcraft. One evolutionary, one revolutionary. And that may be the biggest twist of all. The Blackhawk has always been seen as one of the most traditional military helicopters in the world. A troop carrier, a workhorse, a flying truck. In 2026, it is becoming something else as well. A bridge into autonomous military aviation. Not a concept, not a rendering. A real aircraft delivered to the Army, with the hardest part of the autonomy argument already answered. Yes, a Blackhawk can fly itself. The only question now is how many missions militaries will trust it to do without a human hand on the controls. What are your thoughts on the H-60MX Black Hawk and U-Hawk? Let us know in the comments below. If you enjoyed this video, don't forget to give us a like and subscribe to our channel to get our latest videos straight to your notifications.